Test?
Test yours?
Yes. Okay.
So welcome to Desktop Virtualization Best Practices. This is titled Chapter 2, OS Streaming. Pierre and I both did Chapter 1 last year at BriForum, both in Europe and actually, no, Chicago, I think we only did Chapter 1. No, it was both?
No, last year it was only in Chicago, I guess.
Yes,
only
one place.
Yeah.
So we'll go through introductions in just a moment. I do want to mention, if any of you guys are on Twitter, if you like tweeting about things, there's the BriForum hashtag as well as Pierre and myself's Twitter handles. So really quickly, not going to spend a lot of time with the introductions, but my name is Shawn. I'm a Chicago-based consultant that does a lot of work with large enterprise organizations, primarily in Fortune 500 large enterprise that do financial services, insurance, banking, all that kind of stuff. I do a lot of speaking at events at BriForum, Citrix Energy, VMworld, TechEd, those type of places. I also do an independent training class on terminal services and RDSH and Zen Desktop with Dr. Benny Trich, who was standing here a minute ago and has disappeared. And I'm also involved with TechTarget. I do a desktop virtualization roadshow, predominantly within the United States, which doesn't help you guys much, but Brian does some in Europe. So I do those with Brian Madden and Gabe Knuth. So.
And I am Pierre, and you may know me because of citrixtools.net and NorthScale, a company I've created that is now providing, let's say, new product really from the community and designed for end users and administrators. So if you do not know them, give them a try. You can download everything on the website and feel free to ask me any question. I'm still doing also like consultancy for biggest account like 50, 100,000, 100,000 users deployments because I've done this for, let's say, more than 12 years now. So I'm still involved in teaching them how to automate, how to solve some issues. And I think that's why we are here to share lots of our experiences that Shawn and I both have on this topic. And now on a new topic that is, let's say, in the continuity of Chapter 1.
Cool. Do you want to say anything about VUEM or Transformer?
I would say VUEM is a workspace management solution, so a newcomer on the UEM market. And the goal is to say it's as easy as it can be, and it gives the users the fastest possible login times. So it's also optimizing the performances on the desktop. And Transformer, I'm proud of this one because it's from the community. It's converting any Windows PC into a thin client, let's say, at the click of a button. So if you want to know more about this and on how we partnered with a community guide to achieve this goal, again, you just have all information on our website.
Perfect. So I want to go through the brief agenda of what we're going to cover. We're going to do a very, very quick overview of some of the Chapter 1 conclusions from our prior presentation. If you guys, has anyone seen Chapter 1 on a recording from BriForum Chicago last year? No? Okay, very few people. So I don't know if that video is publicly available yet, or if it's available. I don't know if that was one of the ones made available yet.
Maybe not yet.
Okay, well, we'll find out, and I don't know. I guess if you write me on Twitter, I can tell you if it's available or where the link is. But what Brian typically does with BriForum is if you attend a BriForum, he makes the previous year sessions or the next year's sessions available to you, so that kind of helps out. We're going to do a very quick review of Chapter 1 conclusions, and we're going to spend some time talking about sort of what PVS does and also what PVS does not do. We'll cover different types of PVS images, gold image creation process, write cache types, PVS optimizations you can make, how do you design PVS to be highly available, and then we'll kind of wrap up at the end. So I think we're just going to kind of trade off on a couple of these and talk through them. So
we have one of the best practices we presented in Chapter 1 was if you are virtualizing XenApp or even RDS, do not overcommit vCPU or RAM and just keep it tight to the resources you really have on your server.
And this doesn't mean necessarily that you can't do any overcommit. It's just that the workload profile of a busy terminal server or a busy virtual desktop means that if you start doing too high of a commit ratio on the CPU side, you end up with processor scheduling issues. And if you do too much overcommit on the RAM side, you end up with a lot of swapping. So if you want the optimal performance, don't overcommit the vCPU or RAM. And on the vCPU side, it's the number of cores that are in the system versus the number of vCPUs that you're allocating. Wherever possible, 1-to-1 is ideal. If you want to try to squeeze away 2-to-1, 3-to-1, that's probably fine. But you see some of these guides from vendors that say, oh, 10-to-1 consolidation with virtual desktops. That's lunacy. It's not a good idea. Unless your desktop users are running Notepad all day long, then maybe that's doable. But with a typical busy worker, you can't do that. Right-size VMs, this one might sound obvious, but I run into a lot of customers that take the desktop mindset of what they do in a physical desktop and just transform it to the VDI space. So they say, oh, we're buying PCs that have 4 gig of RAM, or the case may be, so we're going to create VMs with 4 gig of RAM. But the problem is the server RAM, of course, is more expensive than the desktop RAM, and if your users don't need 4 gig of RAM, then you can bring that down to a more reasonable 3, 2, 1, 1.5, somewhere in there. So measure your environment, measure your desktop environment, and right-size your VMs accordingly.
And you also need to understand the IOPS, and even with PVS. So this is important to know it. Having like hundreds of VMs with a small SAN or a small NAS, you can have issues. And you need to know, even when you are using local storage, that you need to meet the IOPS needs and that the XenApp and XenDesktop workloads are really IO consuming. And it can be read IO and write IOPS.
Yeah, and on the IO side, you've probably heard a lot of these things of, 10 to 15 IOPS for Windows 7 user. That's just absolute lunacy. That's, they're calculating based on averages. They don't calculate for the peaks, which is very, very damaging in a virtual desktop environment. And the thing that I always convince people of to say why designing for averages is a bad idea is keep in mind a typical SATA drive in a desktop PC or laptop can serve upwards of 60 to 120 IOPS on a typical SATA drive. Now, if you use that average of 10 to 15 IOPS per user, then why would anyone in their right mind ever buy an SSD drive? If you've got a drive that can already serve 80 to 120 IOPS, why would you ever need an SSD? And the answer is because while they might calculate this moving average of how much IOPS you have on average, you can easily spike to hundreds or thousands of IOPS when you do certain operations on a PC. So that's a bad idea. So I know Pierre has a particular viewpoint on this. So maybe I will address this issue because I'm not tied to a product that relates to this particular case. But when we talk about group policy preferences, administrative templates, how you design your user environment, administrative templates, ADMs, are legacy technology. You should be moving away from those in all cases. I personally love group policy preferences. I do 90% of what I need to do in customer environments in GPP. And in certain circumstances, a UEM tool like an AppSense or a Res or a VUEM or these types of tools are important. And we didn't cover all the specifics right now of when you choose one of those, but we did cover that in Chapter 1. So grab that video.
There is also something important regarding this. And I will not talk about UEM, I promise. But you have Carl Webster as an optimization on how Active Directory can break your virtualization environment. And you should really see this section to see the impact of a badly designed Active Directory, of badly designed GPOs, GPP login script, and how they can break everything.
Yes, a great session. And definitely check out Carl Webster's session. We spent quite a bit of time talking about folder redirection and your RDSH home drive in the case of XenApp and RDSH environments. And I think I stand in opposition to what a lot of the Citrix consulting people talk about this, and many people are very fond of folder redirection in the CCS world, and folder redirection, I tell you, is responsible for large amounts of performance issues in your environment, whether or not you actually see it. It is the greatest sapper of performance in a virtual desktop and RDSH environment. So we talked quite a bit about this topic last time, so I'm not going to go into detail now, but it really does cause a lot of performance issues, so be aware of that.
And XenApp, XenDesktop, actually any solution, even Windows, is not tuned out of the box. And it needs, let's say, lots of small changes. And this is almost like art, because this is lots of really unique values that does not bring maybe lots of stuff from a unique point of view, but when all done together, can really bring a stable and performant environment. So we have talked about this. And we have talked how to optimize the environment. And we will also go further here in this session with what's applied also to PVS and what's unique to PVS.
And along the lines of what Pierre is saying, one of the things you want to be careful with is For many, many years now, going back to the old Citrix Metaframe tuning tip stock that Rick Dellinger created many, many years ago for the early Metaframe products, I always tell customers, be very careful about taking optimization packages that you find on the internet that's just this big reg file that you merge or merge this GPO and it will solve all your problems. I have had numerous customer environments that were broken because of one of these packages. And sometimes you don't always know what's inside or what the impact of these changes are. So I always suggest to people, please go out and get the Login VSI tool or do some kind of baseline benchmarking of your environment both before and after these optimization settings to make sure A, that you're not breaking your applications, and B, that you actually are in fact increasing density, because in some cases some of these settings will actually, in your environment with your applications, might actually reduce scalability. So it's very important to test. So you want to talk about why chapter 2?
Why chapter 2? Because we have seen PVS implemented of numbers of sites, because it's more and more used, and obviously Citrix is pushing customers to use PVS. And what I've seen is that as PVS is not tuned out of the box, I have seen lots of environments where it has been removed or it was working so bad that the customers were like, help me, help me, help me. You know, something like servers, it was XenApp servers booting. You have half of the server that is not rebooting properly, 50 minutes to get a server to boot up. And you can look in lots of KBs, lots of stuff. And this is all about experiences, giving feedback. And PVS has some unique parts that makes it really tight to the environment and really tight to the customer environment.
It's like a voodoo black magic.
Yeah. So even if you talk about some kind of best practices, there are best practices for that kind of environment. There could be other best practices for another kind of environment. And that's where we need to be careful. And if you look at the actual documentations, you will have maybe for PVS 5 dot something. This is the best practice. For the 6, there is a new one. And what about the older one? It still applies, but in some circumstances. And we have really found that even we were lost, you know, and this is only experiences. So we decided to write a little bit about and to share with you. Actually, not what we could call best practices, like generic best practices, but mainly feedback from how we achieve to make it to work correctly. And this is now. Then you can also ask the question of: are there some mythical best practices? I think when it's always changing, you can't say that. And it's the way our industry is working, right? Something that was true yesterday maybe will not be true tomorrow. Something that is true with XenApp 6.5 may not be true with Excalibur. Then it will then become true again with the next version. And that's also something that I find quite exciting with our job, because it's always game changing. You need to always adapt. And so we will talk about some best practices that could be, let's say, useless now or may still have some sense, but only in some specific design choices. It's okay. So the first one, like mythical best practices. PVS should be physical, not virtual. I don't know if you remember when Citrix has bought Ardent. It was the first PVS 4 dot something. So best practices was to have PVS physical and never virtualize it. Otherwise, you can have lots of troubles. I would say that's the best practice I've followed a lot. And actually, then Citrix blogged, and we have even had lots of threads on various mailing lists saying when PVS is virtual, it's working fine. So, and then Citrix decided to say, yes, it's fine when it's virtual. But, I like the but, you know, like the little star in the middle of the text, and you have the explanation at the very bottom of the document. But if you are reaching a certain amount of streams, of concurrent streams, it's really a good practice to dedicate the NIC to the virtual machine. So it's just like, it can be virtual, but it can also make sense to dedicate the resource. So what I've found in my experience is that when it's physical, you don't have the issues you can have when it's virtualized. So, and when it's virtualized, if it's a small environment, you don't have to dedicate the NIC. By small environment, I mean less than 100 streams, 100 concurrent streams on the PVS server. The only downside you will have is that your boots, the boots of your streamed VMs will be really slower. And by really slower, I mean can be up to 1 minute more to boot the VM, and then you will have a black screen. You can look in the forums for PVS black screen. You will see what I mean. You can have a black screen for like 60 seconds. As soon as you will have dedicated the NIC, but then you lose some of the benefits of the virtualization stack because you really dedicate the virtual, the NIC to the virtual machine. So you can't use vMotion, you can use XenMotion. It's sticked to the hardware. So in some cases, I've had customers that say, okay, use a physical server there. It's no sense to dedicate the NIC. All these problems are back, and you can scale now with the new 10 gig network cards, for example, to thousands of concurrent streams. So I would say that the fact that it should be physical is not so true yet, but if you clearly understand that on huge environment, dedicating the network card is not an option, it's mandatory.
So second one is segmented VLANs. For PVS streaming, having a completely separate network segment you do your streaming across. Used to be very, very common practice with PVS over the years. I have not been doing that for a number of years now, and the reason is that given the bandwidth you typically have on a gigabit or 10 gig interface, you're not going to reach a point that your other traffic on that network is going to cause you problems. Now, the exception to that might be if you have high volume backup happening across your shared NIC. You may run into some issues in the times when the backups are running, but in most cases, that's not going to be that impactful because it's off times of when your XenApp usage is typically done. But in most cases, I'm using the same network interface that I'm using for streaming that I am for other things in the network. So not dedicating separate networks to that. So very common practice now.
Yeah, I would say that can also depend, and that's where, it's working, okay? Yeah. The question, if the question is, does it work? It's working perfectly without any issue. But you all know that each customer is kind of unique. And if you need to insert a new DHCP, if you already have some kind of PXE server to install the servers, then you will need to adapt your design and to have a separated VLAN. But it will be like an architectural decision because in the customer actual environment, this is the only solution you do have because the customer already has DHCP, PXE, you want to separate it, and then it will not be, let's say, enforced by the product, but it will be your own choice or the customer decision because of some environmental constraints.
The next one, MCS is for small customers, PVS for large. I think this is actually like verbatim out of the Citrix eDocs and presentations and that kind of thing. It simply isn't true. And I think the reason why Citrix makes this assumption is because the I/O profile for an MCS solution versus a PVS solution is about 1.5 to 2 times more I/O than a relevant PVS solution, particularly on the read I/O because of the caching that PVS is providing. But the reason why I say this is wrong is this is driven by your storage performance. And if you don't have a storage performance problem, either because you're using a third-party solution like an Atlantis Ilio, or you've got some kind of Fusion I/O cards, or you've got some kind of tiered flash cache storage subsystem, then MCS is actually completely fine and is absolutely fine to use for larger scale environments. So this is sort of a safeguard statement that says use PVS for large environments, use MCS for small environments, but it's absolutely not true. It's just driven by the storage. So the Citrix guideline, I believe, is 500 or below targets or total deployed virtual desktops or servers. Again, MCS can scale as large as PVS can if the storage subsystem allows for it. It's a general guideline that because storage is often constrained, to be on the safe side, you want to use PVS over MCS to avoid the storage issues. So that's the general guidance.
PVS doesn't require a CCM. This is not because you are using PVS and you have the ability to, let's say, install applications manually into an image, that you don't need any software distribution engine. And it's even better if you can build your golden image with that kind of software. Because you have something that you remember. It's just not like when the admin decided to add this registry entry or to install this small application prerequisite that was missing manually. And then, some months after, you just have forgotten that it was installed, and you don't know why it's working in this image and not in the new one you have just built. So even if you have the single image management, if you still have an automation engine like can be SSM, Altiris, or other software deployment engine, you may still use them with PVS.
And I like these solutions because, to me, it creates a form of self-documentation. Even if you have good change management procedures and you're using PVS and you have a change log and everything gets documented that goes into the image, sometimes admins make mistakes. They forget things. It just doesn't get in the documentation. And then, as Pierre said, you end up with a deployed image that something doesn't work. Nobody knows why. If you take the time to do the automation ahead of time, you never run into this. And it's self-documenting. This is the one I love because I have this debate and conversation with people all the time about VDI instances and thin clients and all these kind of things. And people say, it's stateless. You don't need antivirus because you just reboot it to clear it. So what do you need antivirus for? And here's the problem. Viruses that are wormable, if a machine gets infected, it's going to be spreading throughout your network for the next 4 or 8 hours until you reboot it. And if you think you're faster than the computer code, that you can just run around and reboot all the systems to clear it all out, I'm telling you, you can't. I spent a very long amount of time at a customer site fighting the Nachi worm way back when, and we just could not get around fast enough to clean systems off and segment the network and close things down before this thing spread. It was very, very rapid. And that's not to say that in modern days everything's wormable, because less and less things are becoming worms, but this is just a silly statement that you don't need antivirus because it's stateless. You absolutely do.
But actually it's easier to say that you don't need, because you can have troubles with PVS and antivirus.
Oh, sure, of course. Yeah. It's not to say that it won't cause you performance problems, because let's be honest, 90% of our performance problems are due to antivirus. But don't think for the security aspect, you don't need antivirus.
So PVS is easy to implement.
Yeah, right.
I would say it's easy to implement. It's not really easy to make it work
I say
correctly.
it's easy to install. It's not easy to design or architect.
Yeah.
I think that's probably the better way to look at it.
And if you want to deliver really a good user experience, you need to make lots of stuff and to prepare lots of stuff. Also, it's not easy to use, I would say, even on top of implementing.
There's a lot of things that can go wrong that can blow up the PVS environment that if people haven't heard about or planned for, it can be a sort of rude awakening that can hit you. So single image management, we're gonna talk about this a little bit later, but the idea behind PVS, of course, or any of these kind of cloning technologies, is the notion of having a common image management platform, and we'll talk about where that's true and where that's not true in just a bit. So this is a good conversation to have.
Yeah.
So PXE versus ISO or boot volume. In a PVS environment, to make things so that you can boot the VMs and connect to the stream service, you have to give a bootstrap component for PVS so it knows which stream server to talk to. And particularly in a well-designed PVS environment, you have HA, so you have 2 stream servers set up that you can fail over to and that kind of stuff. The challenge always comes down to designing PXE for high availability, or designing PXE to work within an environment that has other PXE services like an Altiris or WDS or something like that. You do have to get into what we were talking about before about the segmented VLANs and IP helpering rules and all these kinds of things. So an alternative solution to doing the PXE-based approach is you can do boot ISO method, or you can do a boot volume that has the bootstrapper loaded into that. Now, the pros of those approaches is that I completely eliminate the need for PXE. That doesn't mean that I don't need to have high availability around DHCP, because I still have some dependencies on there. I don't need to have high availability on PVS, but it eliminates the PXE piece of high availability and allows me to co-op with other PXE-related services in the same environment. The downsides of the boot ISO or boot volume mechanism is if you go with the ISO approach, depending on how your hypervisor operates, you may have issues where the ISO will not retach on a machine boot, or it gets disconnected. You might lose some motioning capabilities because of that. And in some cases, you may have issues in terms of the scalability of VMs tying them to a particular boot ROM, because you may have limitations like vSphere, this is true. You can only have a certain number of VMs connected to the same file on a particular SAN LUN. So you may have a limitation built in if you have a few hundred target devices that you either have to duplicate the ISO in multiple locations and bind the VMs independently to the ISOs so you don't overrun the built-in limitations in the file system. So the way to get around that is either to put the ISO local on each hypervisor and mount it that way, or to use the boot volume method where you create a small partition that you load the bootloader into, and that's what the machine boots off of instead of the boot ISO. But none of these solutions are ideal because they're not automatic. You have to go in and build some scripting framework to allow this to work properly. So it's not ideal.
And I think that's also one of the main points. When we say it's easy to implement, maybe not easy to manage. There are lots of things that you need to do manually.
Yes.
And we'll talk about them.
Yeah, absolutely.
PVS is really critical. And we have seen, both of us, lots of deployments with only one PVS server. And let's say maybe relying on vMotion, I don't know. But when your PVS server is down, all the streamed VMs are down. So when the PXE service is down, your VM cannot boot. And also PVS is relying on SQL. There is an offline capability that is actually working when it has...
Sort of.
Yeah, when it... I was about to say, when it has decided to work.
Yes.
See what I mean? Sometimes it is, sometimes it's not, and you really don't know why. So I would say do not rely on the offline DB capability. Actually, the database is mainly needed at boot. So if you have an outage, it will prevent any computer to reboot, for example. But all the VMs that will be actually streamed will continue to work. But you need to think about it and use mirroring or clustering on the SQL side, just to ensure that it will be highly available. Because offline mode, you can turn it on, but you can just pray for it to work the day you will need it. So.
And some people view the PVS high availability as I'll just use hypervisor HA mode for that, which it might be an acceptable solution depending on your outage window. Keep in mind, hypervisor HA basically means the VM is going to get booted on another system when that system fails. And so the challenge you have around that is there's going to be a period of time where it's going to be down. So if it's occurring with when VMs are getting rebooted, you're going to have this period where none of those VMs boot, and you're going to have to go in and clean them up by restarting them and that kind of stuff. So it's not a perfect solution.
Shawn,
Yes.
could you briefly cover the VDIS location availability with a block local kind of NFS sys?
Yeah, we'll talk about that a bit in just a moment. We got a slide talking about that. So, do you want to carry this one?
PVS optimizers, yeah. PVS optimizers OS, because in the image builder, if you have used it, you have lots of tuning options. So just like if you just click the button and everything is working, would be really cool, actually. Yeah. But actually, the optimization that is done is not really to optimize, it's just at least to make it work. Yeah. Disabling all that you need absolutely to disable, like system restore, for example. In a streamed environment, and mainly in a stream shared environment, to be exact. But out of the box, it does just what it needs to work, let's say, by default. And it will never accommodate lots of stream machines, like hundreds, like thousands of streams, because it's not optimized to do so.
Yeah. And we'll talk about those optimizations near the end. So we're going to keep clipping along so we don't end up running out of time. So I want to talk about two things. One, sort of what PVS is and what PVS isn't. And I think there's a lot of confusion for the way that PVS is sold and what people are using it for and what the real true benefits are. So I want to cover from my perspective what I believe PVS is for a customer-based solution. First of which, it is a read I/O caching solution. I'm specifically highlighting read I/O caching solution because it's not a write I/O caching solution. So the system RAM dedicated in the PVS server is simply taking blocks of data, probably from your SAN, where your base image is being stored, rigging it into Windows System Cache, and then using that as sort of like a fetch location so that any additional targets that are reading those blocks of data are being served out of RAM cache as opposed to going back to the SAN. So what we know about read versus write profiles in a XenApp or virtual desktop environment is that during boot, we typically have a 90% read I/O operation and about a 10% write I/O operation that occurs during the boot process. When we start to shift into production usage in steady state, we shift to about 80% write I/O and about 10 to 20% read I/O. So the problem is that PVS solves the boot storm issue because all those blocks of data are being cached. What it doesn't help you with directly, and we'll talk about ways it can help, is it doesn't help that write I/O problem. And so we'll talk about that in just a minute. The second thing is PVS contains what I'll simplify and call a disposable write filter. Citrix calls this a write cache, but basically what it is it's a portion within the file system that all the writes that get that happen to that lockdown read-only VDisk image get redirected to this write cache location. And the idea of the write cache is that when the machine reboots, the write cache is flushed. And what's ideal about this for a XenApp environment is oftentimes you don't want the XenApp machines to deviate from one another at all. You want them to be byte for byte identical from boot to boot. And so what's great about this is that any changes that happen, including things like user profile and page file and all these kind of things, are discarded at the boot of that machine. So if you boot your VMs on a regular basis, you're going to have basically virgin VMs every single time you start up. This is fantastic for XenApp. Virtual desktop, I'm kind of mixed on, because in the virtual desktop world, I think it's extremely hard to achieve common image with any level of scale. And because of that, I don't believe PVS has as much of a value proposition in VDI, but we'll talk about that more later. The second thing is, and this is important to a lot of admins, is that it is a solution for image management. And you can debate whether doing image-based management or system-based or product MSI push-based like SCCM makes more sense. I usually say it depends on the size of the environment and the proficiency with PC lifecycle management. If you're great at SCCM, then maybe image-based management is not going to be a great thing for you, because you're going to have to always keep those image updates in step with what's happening in SCCM, and that can be challenging. But it basically allows you for rapid cloning of target machines, easy roll back when something's broken, and easy roll forward to new versions of images. These are the three primary things PVS does, in my mind. What PVS is not. Here are the things that I think a lot of people have misconceptions about what PVS does for you. It is not a write I/O caching solution. In fact, it does absolutely nothing to help the write I/O solution, with the exception of potentially offering tiered storage, and we'll talk about how the tiered storage can actually happen. It is also not suitable for high application diversity in my mind. What I mean by this is it's designed, as I said before, to take one single image and roll it out to 50 identical machines. PVS inherently gives me no capability of letting those machines be different. That's sort of the whole purpose we talked about with that write filter. So if I have a lot of diversity of different types of applications I have to serve, I either have to maintain multiple parent images that I'm going to share between all those VM targets, or I have to combine something like application virtualization with PVS in order to get that differential, or a Windows layering technology like cloud volumes or something like that. So it doesn't really support high application diversity requirements.
And just to add to this, PVS and application virtualization solutions.
Oh, that creates a lot of problems.
That can create a lot of problem as well. So you have to do it really carefully, and just forget about some marketing dreams that are saying we have only the OS-based image with PVS and all applications are streamed and everything is working fine. Actually, it's not.
We'll talk in more details in the write cache portion about specifically how AppVirt affects things. The next thing is suitable for fully persistent desktops. Now, the Citrix marketing people would argue against what I'm saying here and say, like, well, you can use PVD in combination with PVS, and you can get full user persistence and all that kind of stuff. But the problem with PVD is it doesn't really solve the problem either. It simply puts a Band-Aid on it and moves it from a C drive problem to a P drive problem. So that's not really fixing the problem either. If you want fully persistent virtual desktops, there isn't any way to solve this in my mind than fully persistent virtual desktops today. There are some technologies like cloud volumes that can get you much closer, but application virtualization or fully persistent desktops is the way to go. Doing it with PVS is not really a great approach to that. And most importantly, as Pierre already talked about before, it's not a reason to abandon well-managed desktops. If you have a good PC lifecycle management practice, don't think PVS will be your savior and means you never have to deal with pushing software and maintaining software inventory and that kind of stuff. You still have to deal with this. You want to cover the image types?
Yeah. So we have in PVS you have different images. So images are basically VHD files that for the root image and AVHD for the updates. So you can enable images in private mode. So that's really, from my perspective, I don't use private images in production because this means that the image is available in read-write access. So you use the private image mode to create the image and to update it. If you use it in production, it means every user has his own image, or every XenApp server has his own image. So you just move potentially the C drive to a VHD, but that's it. And you have all the streaming stack. Yeah, it does not solve the problem. But then you have the standard image, and the standard image is read-only. Actually, it could be read-only or it could be differential, but because the base is always a standard image, it's not even differential. This is so the shared image is read-only. So everything is committed to some cache, and we'll take the caches a little bit later. And so the image does not change from time to time. This is really useful in XenApp environment, as you can avoid the effect of your operating systems getting older from time to time. You always have something clean after you flush the cache. And you have what Citrix calls the differential image. And actually, it's a shared image, but the cache does persist after each reboot. Whereas in standard image mode, you reboot, you flush the cache. So the only difference is where the cache is located and that it's not flushed.
Yep. So sort of a graphical version of this. In private image mode, the target device can read and write to the vdisk. So think of this nothing different as having a VMDK or VHD sitting out on your SAN. And you basically have 3 different target devices. Each one has its own separate vdisk or VHD. And each one of these is a read-write copy of a complete C drive volume, so 50 gig or whatever your disk geometries are. And you're going to have 3 copies of that sitting out on the SAN or sitting out on the PVS server. And so it's going to take up lots of disk space. And you're not going to get the other advantages that we talked about within PVS. So requires the most storage. Changes are persistent. You don't get the benefit of the common image management. And it also requires the most I/O from a read-write perspective. Standard image is kind of the one that kind of Pierre already talked about, which is the target devices only have read access to the image. And there's effectively a write filter that gets created. So any write changes that would occur end up into the write cache, and the write cache can be put in many different places, and we'll talk about the places where the write cache can be placed and what the benefits are of each. But the idea of all the writes going to this write cache are in between reboots of the system. That machine goes back to basically similar to a snapshot. It goes back to a snapshotted state, effectively. And the differential image is sort of the best of both worlds, only it doesn't really work so well. And that is that you start with a common shared image, so it has the same base vdisk, but any writes that occur on that target machine get created as a separate differential disk, and that gets stored up on the PVS server, where it can then be reapplied as an overlay on top of the machine the next time it boots. So all those changes persist between reboots, which is awesome if you need that differential changes. The big problem with this is if I go back and touch my master vdisk on my SAN or on my PVS server and I change its contents, it automatically erases all my differentials. So if you're familiar with linked clones in the VMware world, operates much the same way, that you lose your differentials when you update your master. So this is not a great solution.
It's not a true layering solution, actually.
True, correct. So goal image creation. I want to take this first one here and kind of talk through this. The issue I have from a marketing perspective is all the vendors out there that sell you what I call the snake oil around common image management is it's kind of situation where they tell you one image for all your servers, one image for all your desktops. I like to think of this as the used car salesman approach, because it's like just one image for all your desktops and all your servers. It sounds great in practice. The reality is, unless you're in a very simple environment with a handful of applications and no real change requirements within your environment, the whole idea of having one singular image that's going to satisfy every single XenApp server or every single virtual desktop is almost impossible. Now, places that you can use this more tactically is to say, I've got 500 call center users that all need the same 5 applications. Can that be one image? Absolutely. No reason to not do that. However, if your call center is simply one of 15 different profiles, and I don't mean profile in the Windows profile sense, but different types of users and different sets of applications, I may have 15 unique applications to support that under PVS. And the problem with 15 applications in PVS versus 15 applications or 15 different image configurations in SCCM is in SCCM I have infinite amounts of deviation that are possible. In PVS, every gold image has to be updated uniquely. So I got to go take my images. Every time I have to update them for Windows patches, where the case may be, I got to crack them open, make the changes, reseal the image, and put it back out there. So this can become very time-consuming if I start growing the number of images I'm maintaining.
I would say that also, if you have a well-managed environment, it will not be one image.
Yes.
It will be multiple copies of the same image.
Yeah.
So, because you will need, if you need to manage your changes, to have the previous version,
Correct.
to have the current version, to have the upgraded version, and you will swap and switch between the images when you will do your change or update your application. So even the one image miss is not really possible unless you just update the production image without any rollback possible. And then it's your decision. I will not advise to do this.
Yeah. And likewise, if you're working in a distributed environment with multiple sites and multiple PVS servers, you of course have to replicate these images around. So you can end up having a lot of disk space taken up in a lot of different sites. So this can be challenging. So
yes. First, just something I think we forgot to mention. This is something that you really need to know about regarding PVS. Microsoft is not supporting the way PVS is cloning the operating system, which means, and I have faced that with big accounts, where Microsoft support said it's not supported. Citrix support answer is we are partners, like it's not, and we will support the issues. So you end up in, let's say, Citrix saying that they will support Microsoft issues through their partnership support agreements, which is really cool, but not from a customer perspective. So you need to know that because you can have some issues, like political internal issues in case you have one problem, and always keep a way to reproduce your bugs without the PVS stack.
Yeah.
Which means if you have a golden image on a VM, keep the VM. Even if you shut it down, keep the VM and make it evolve, patch it like your golden image so that you are able to reproduce. Also, sometimes Microsoft can say if it's not Hyper-V, you need to reproduce on a physical computer. But,
they've gotten better about that, though.
But you can have that one. I think you need to keep the copy, otherwise you will have troubles when you try to debug something. So then, the golden image creation is really touchy. First, because you need to know all your applications. And believe it or not, but there is an order in the way you need to install your applications, because some of your applications may install a filter driver. Could be all kinds of applications, actually. Because IBM Client Access for AS400 has a filter driver. And if you install it after PVS, it's breaking the PVS stack. So any antivirus or firewall software has a filter driver, obviously. And PVS needs to be installed at the end of the chain so that it's then pushing the informations all over the chain. Also, drivers are really important regarding network. So if it's physical devices, you need to know that you will be tied to only network card devices. And then you need also to know all your softwares if they need some ideas, if they need some unique values to be resetted. If, for example, some applications are storing computer name. Otherwise, you will install your application, and then after the image will be dispatched to lots of servers, they will all pop up with the same server name. And that's something that Citrix is not providing anything to manage it. So you need to have your application science. It's really good if you always have, for example, VM cloning experience, because you have had all this issue.
Yeah.
Also, with VM cloning, it's not unique to PVS, but you will need to find some way to automate this. So we will talk about this a little bit later as well.
And along those lines of what Pierre was talking about, Microsoft doesn't support any mechanism other than sysprep. And unfortunately, sysprep is incredibly I/O intense and incredibly CPU intense on a virtualization platform. So if you had to run something like sysprep, you could run it, but there's a very, very large impact of that. I've been saying to Microsoft for years now that you really need to fix sysprep and make it more like some of the other vendor fast prep solutions. And they say, yeah, we'll do it someday, but it doesn't seem like it's a priority.
It's like the never-ending story. You have a blog post from Mark Rusinovich talking about utility of keeping SIDs resetted, and you have Microsoft support saying, this is the only way of doing it.
Yeah,
well,
true.
This is a support decision.
So, image creation?
So, regarding image creation and image change, because we have lots of experimented guys here. We may have also lots of people that are working for integrators. We may have also some people that are working for customers. Just when you are an expert, you can do anything. You can script everything. And for you, it's easy. But you would be surprised to see in real life environment how many images are not updated, how many are not updated correctly after any change. There is a utility called Xenap Prep. I've been to various customer sites. When you update your image, are you running Xenap Prep? No, why? Why should I? And that's the same, even for edge site, even UPM has some file caches. It's documented in the end, at the bottom of a knowledge base article digged somewhere, but you have some caches. And that's the same for all your applications. So the only way not to forget something is to automate. So you can use scripts. That's why some years ago I've developed the cloning tool, the Xenap cloning tool you may know about. Because the idea is that you have a utility that can also schedule some scripts at specific events like before image update, at image startup, before XANAPP is started, after XANAPP is started, actually, just so that you then have one button, do cloning. The customer has one button, clone image. That's it. And that's something we should never forget, is that we can do lots of complex stuff and we understand the whole stack. But often the customers are relying on our expertise. And then, even if they have some in-house expert, there are not 20 in-house experts. And that's not the in-house expert who is doing the change. That's the guy at the end of the production layer that is just paid to push the button. And if we forget about this, this could really lead us to lots of issues. You know, like XANAPP, it was working the day before, it's not working after the reboot. And when you change PVS, you just ask PVS to change the image. You could see only the effect the next day after all the servers have rebooted. Yeah. And we are also working on making this available in a really full stack product that is called Project Andromeda, and it will be released in September. And if you have some question about it, feel free to ask me or to send me an email.
And this is, by the way, this is a best practice in my mind, even in the absence of PVS. And I can tell you from a particular customer example that I was working with a couple weeks before I came here, we were just doing straight up VM template clones. And what we ended up finding out was there's this whole stack of software, about 24 software products we have to put down in this new financial services image for this hedge fund company. And we developed all the stuff based upon documentation we were provided, and we were trying to make a decision early on the project if we were going to automate the installs or we were just going to manually install based on the install documentation. And I insisted with the customer, even though it would take more time, that I wanted to do installer automation. So they reluctantly agreed to let me take the extra couple days and do all the automation. So did all the automation. What ended up happening was, after sysprepping and cloning the machines and we deployed them, we had an issue where Explorer would not function properly on the machine. Something went wrong in the cloning process that it failed. And we went back numerous times and tried to resysprep, reclone from backups, everything, it was just failing. So we had to go back and actually install partial package lists along the way to figure out when things went wrong. And we did end up figuring that out, but I think back to the fact that if we didn't do that automation, we would have been going back to the install documentation with a clean template and install the first product from documentation, then clone it, and do the second one and clone it, and basically go through, and we would have wasted a lot of time. But because we had that installer automation and spent the time early on, it made that resolution fairly quick. So it's a good idea to do even if you're not using PVS.
Yeah, I would say it's human, okay? We have documentations that are really complex with lots of tasks. And when I was managing a team of 15 Citrix consultants, I first started with a Bible. You know, it was like Douglas Brown Bible, but let's say quite updated for our methodology. You know, I always had some deployments where one of the registry value was forgotten or was not set properly. Because it's human, you have a documentation with hundreds of value, you can do a mistake. So automation.
Or you type it in wrong.
Yeah. You can, you know, even as a developer, you can forget an exclamation mark, but it would say true or false, and it will be the difference, like true or false in your code. So you can say you will never do it, and automating allows to reproduce it and not to forget it, and not to forget it months after, years after, because the images you will create are not likely to live only for a few months. They will be updated, but that's a base that will be used by the customer generally from 3 to 5 years minimum.
Yeah, and if you're in a customer environment where you don't have budget for tools like SCCM and that kind of stuff, Aaron Parker has done a great session on creating full automation around XenApp and Zen Desktop and that kind of stuff using the freely available MDT tool from Microsoft. And Aaron has published online sample scripts and downloadable kits for MDT to where you can reproduce this on your own. You basically insert your own media, your own ISOs, and your own packages, and you go to town and build a machine from there. So it's not to say it's super simple, but if you've ever worked with MDT before, it's pretty easy to get up to speed on that. So I think we're just going to trade off on this one a little bit and talk about this. Yeah. So PVS write cache types. So when you, and let me just throw all these up here first, and then we'll talk about some of them in more detail. So when you build an environment with PVS, as we mentioned, in that shared image mode, It's a read-only image, and you end up with all the writes get redirected into the write cache. And you can choose where that write cache goes. And where it goes has some very important consequences to you as an administrator and designing your environment. So one of the first cache locations is you can cache on the target device hard drive. Now the term target device hard drive is a bit misleading because all it basically means is in the context of a VM, it's a virtual disk presented to the VM, which it could be a virtual disk presented from a data store that's physical on the blade or pizza box that you're running your VMs on, or it could be a SAN-mounted file system that is attached as a virtual disk to the VM. Now, the important differentiation between these two, if you think about it, is in one circumstance, it's going to be going to the local storage of the blade. Now, this could be good and this could be bad. It could be good because that means you're creating an artificial tiered storage. The writes aren't going to the SAN, they're going to local storage. So whenever you have some reads and writes up here and some reads and writes here, that creates a better performing environment. Where this can go very badly for you is if you have blades that don't have a large amount of local storage capacity, like you've got RAID 1 mirror 160 gig disks or something like that, you may not be able to fit very many write caches before you run out of space. In addition, if you have a high volume of VMs running on top of that blade, you may run into a situation where the two local disks can't provide enough I/O for the number of VM targets you're running on it. Now, if you choose to not use the local storage and decide you're going to park it on SAN, think about that for a minute. What we talked about earlier was the read-write I/O profiles of a Zen app machine or of a Zen desktop machine in steady state are 80 to 90% write I/O. So when I talked before about PVS being a read caching solution and it not doing anything for writes, when you do target device, going back to the SAN, all that write I/O is going up to the SAN, including your write cache and your persistent data. So you're basically not solving the write I/O problem at the SAN layer. So if you truly want to solve the write problem at the SAN layer, you either have to put some tiered flash cache on top of your SAN, or use a software-based acceleration solution like Atlantis Ilio or something of that nature. Because doing it just natively is not going to ultimately fix the I/O issues. So.
Yes, I would add something that is not, I think, not present in the slides, but you mentioned SAN. PVS is actually supporting NAS, like SMB. It's supporting SAN, and this is a decision you have to make, knowing that if you have your images on SAN, it will be a little bit difficult to manage them, because the only way to have the same LUN shared with a Windows file system between two PVS servers, and that's where we have to manage this for high availability, it's to have the LUN in read-only. It has been a nightmare to manage it because it was manual. Now it's integrated, quite integrated, let's say, in the console, but it's still really difficult because you need LUNs that are switched to read-only, so you need extra copy of the image in dedicated LUNs to be able to manage them really easily. My favorite for now is, and I've been successful with that, is to use like NAS type storage, like NetApp filers, for example, in SMB2, so with appropriate tuning, and that we will talk about this, and using image replication and also, let's say, the NetApp or any brand of storage, replication, deduplication stuff, and it's for me the easiest way to manage images, even split it on different data centers. If you want to do more using the SAN and fiber channel, because now we have the 10 gig, we have Ethernet that is also really better than it has been some years ago, you will need some intermediate software layers like, you remember the name of the one Citrix Ardent was recommended? I always forget about it.
The one Citrix added to
yes, it was a virtualization layer for PVS and the SAN. Let's say.
I don't know.
Sorry? Yeah, Melio.
Oh, Melio.
Yeah, Melio,
okay.
Yeah. You will need that kind of virtualization system if you want to be able to share LUNs with the same Windows file system across PVS servers.
Really anything that aggregates storage into a software presented solution. So the next option, cache and device RAM. If you can do this, this yields the very best performance possible. And it should be pretty clear why it's the case. I mean, you're putting your writes into memory on the target server as opposed to letting it go to disk at all. Anytime you go to disk in any form, if it's spinning disk, you're going to have performance issues. You're going to have disk queuing. You're going to have all those kind of things. So going to target device RAM eliminates all those I/O issues, and you'll find that your disk queue length is going to drop dramatically inside your VMs. However, this makes a number of assumptions. It makes the assumption that you have available RAM on your hypervisor blades to dedicate to PVS RAM caching. And it also assumes that you can right-size your RAM cache to fit everything in there that will go as a differential write into that cache. Because unlike the storage one that's a bit more of a circular write, in the case of device target RAM, if you fill the cache, the system can freeze, BSOD, or otherwise just corrupt and lose data.
From what I've never seen freeze. But BSOD, yeah.
BSOD, very common.
And actually, every time I've done a POC with a RAM cache, it ended in a BSOD. So if you like to gamble, you can try it. Because I would say, to be honest, you never know. With the customer environment, there is a new IE update, 100 megabytes for each new tab. Could happen. Knowing what IE is consuming right now, it would be not difficult that an update can break everything. But and then you don't have enough memory. The main issue is that in this case, all your stream machine will be SOD, and that's not really cool. So even if from a performance perspective and from a marketing perspective, we offload to RAM, I would say, for me it's too risky. You can try it. Maybe some people have successful deployments with it, but from my perspective, I would not assume as the architect that has designed the solution that it can be a potential issue.
And while we're talking about that, I think it's important to discuss sort of like what ends up or what lands in your write cache and how big of an issue this is from a cache sizing perspective. So when somebody logs onto the machine, their user profile is going to blow it out into the write cache because that's a write that's going to happen. So depending on the size of the user profiles, that's going to eat up some of your write cache. If you have something silly happening like roaming profiles that are 100 meg per user or 200 meg per user, that's 100 200 meg of your write cache that's going to start to fill out. Things like your page file, depending on how large your page file sizing, it's going to fill up your write cache. In PVS environments, sometimes it's a good idea to reevaluate how much page file you're assigning to your machines and possibly consider shrinking that down if you have adequate RAM and you're not hitting peak values inside the VMs, because it's going to save you your write cache and might prevent this issue that you actually could run within RAM. The third thing I want to talk about with regards to write cache, it's very important, is think about things like app streaming and AppV and anything that is going to involve on-demand streaming of blocks of data down to the disk. Now, depending on which technology you're using, AppV v5 and the recent Citrix app streaming support a shared VHD or shared cache model where effectively it doesn't preload the data onto the machine but reads it on demand as blocks of data across the network inline on the fly. If you're using a solution like that, then this may not be an issue because that's actually not going to hit the disk. It's just going to come through sort of a network redirector. But if you are loading apps into a localized cache, that will all end up in your write cache. And some of the solutions like the old style AppV 4.6 and prior can get really ugly because they have a proprietary file system wrapped around their technology where if you were to preload all the applications into a cache on the base image, that would be cool. That's going to be fine. But the minute anything differentially has to load into that cache, it's going to end up in your write cache, and that's going to be an enormous amount of data that's going to end up there very quickly. So solutions that are based on file system where you can have a differential between what's in the base image and what's going to differential stream, that's better than having one that's going to be in a proprietary large file that's going to get written out to your write cache.
Yeah, I would also add that whatever the cache you are using, you will need some kind of local disk to store data that need to be persistent.
Yes.
So even if you use RAM cache, you will need this.
Yeah.
For example, you will need to redirect event viewer just to, after a server reboot or crash, to know why it has crashed.
I've seen customers that don't do that, which is crazy. You think about it, we talked about the beauty of PVS is that every server is virgin every time it reboots. But think about this. If all your event log data is gone every time you reboot your system, how do you ever do any forensics? How do you ever do any root cause analysis of things when you can't see the event log that happened yesterday at 3 o'clock? It's insane. You have to put that stuff in a persistent location.
To be honest, on all environment I have audited, it was not the case.
Yeah.
So, because it's just not in the best practices or maybe in any law. It's in a knowledge-based article if you have an issue. If you have an issue, don't forget to redirect the crash dump on a local drive. It makes sense, but if you don't have a crash dump, at least even a kernel dump, because a full memory dump now could be difficult from a size perspective. But for each site, you also need that kind of cache, and for XenApp itself. Otherwise, what? Otherwise, the license cache file is tied to the original image creation, which means after 30 days, if you reboot your servers and XenApp license server is offline, XenApp shuts down.
Yeah.
So you need the license file to be moved, and it's a registry hack. So to be moved on a local partition so that it's updated at every new boot of your system.
And another common one as well is your antivirus signatures. The last thing you want to do is bring back an image that you made a month ago, you power it up, and it powers up with a month-old DAT file. So some people would say, well, that's okay because the AV agent's going to pick it up and it's going to drop down the new DAT file and that kind of stuff. But from my perspective, if it's an incremental DAT update, that's a very different resource consumption profile than if it's, quote-unquote super DAT where it has to update the engine and all sorts of other stuff. The resource impact differential is enormous. So I'd much rather put that into my base image update and then only have a little tiny update that has to happen into my, my new machines when they reboot. So the other two we'll talk about very briefly, but I don't think they're all that relevant, is you can cache on server, meaning that your Delta write cache is going to get stored on the PVS server. And this can potentially be really bad if your PVS server's disk volumes are also back on SAN, because now you're basically passing through a Windows Server intermediary that's not optimizing your write I/O and then still hitting the SAN. So it's sort of like a double whammy in my mind.
I think the way I see it useful is that if you configure the target devices to use, for example, the local drive, and the local drive is not existing, it will default to this one. And why is it useful? Because actually, if you want to use a local drive for the cache, it needs to be formatted as NTFS.
Yeah.
So in some cases, if you want to automate everything, it will be formatted only at the first boot. Then, let's say at the first boot, it will default to the server cache, and then after reboot, switch to the local drive cache. So
but not using it as a permanent solution is my point.
Mm.
And then the last one we kind of talked about, the PVS server-based cache location and differential model. And the reason why differential model is so silly is because while it does allow you that persistence of data, as soon as you put your disk in private mode and want to make changes to it, it whacks all the differentials. So you're going to lose all the things you wanted to persist in the first place. So that's kind of a silly approach. So let's talk tuning.
So I would say, like XenApp, I think you have lots to do in terms of tuning regarding PVS. So regarding reservation and resources reservation, dedicate them. Do not do ballooning, all that kind of stuff. The recommendations, and that's what I've seen from real-life environments, is around 10 gig per image you are streaming. And also, you will need to optimize the way OS is managing this memory. So we will include some registry values dedicated on tuning, and we can provide lists of them if you just send an email or to any of us, and you will have all the details.
And I'm very surprised, by the way, on the vSwap thing, because I can't tell you how many hypervisor architects I discuss in virtual desktop projects where I say, we're doing persistent VDI images, here's the number of machines I have, here's the C drive content space. And they're like, well, that means I'm going to need to have this many terabytes because the vSwap allocation and blah, blah, blah. And I'm like, wait a second. We don't overcommit RAM. We give 2 gig per VM or whatever. Why don't we set a RAM reservation which eliminates vSwap? And almost immediate response back is, well, that kills vMotion. And I was like, no, it doesn't. It killed vMotion a long time ago, but it doesn't kill it anymore. You can vMotion, it takes a slight amount longer time, but you can vMotion without having vSwap. So dedicate your RAM allocations if you're not overcommitting and you're not ballooning, and that completely eliminates vSwap, which means when you're sizing your SAN, you don't have to allocate this additional storage space to match the RAM allocation per VM because you're guaranteeing that amount of RAM. So there's no reason to allocate vSwap. So this is a great idea to do. Next.
So if you're using CIFS hosting for the PVS server, like SMB1, SMB2, tune the operating system on the PVS server to accommodate the storage type, because letting Windows like auto-discover the SMB features and trying to auto-adjust will just lead to slow performances and random disconnections. So we have talked about this in chapter 1. You have lots of articles talking about this. If your storage is SMB1, tune Windows for SMB1. If it's 2, tune it for SMB2. And
by the way, don't ever trust your storage people.
Yeah.
Because I had a number of NetApp engineers at a customer site of mine that were insisting that they were supporting SMB 2.0 until I showed them a Wireshark trace, and I was like, we're not getting SMB 2. And they're like, oh, okay, and they went and checked, and they're like, oh, sure enough, we don't have it enabled. I'm like, well, that explains the performance issues.
Also regarding NetApp, there is a known issue with PVS, where the NetApp storages are not releasing some locks on the files, which makes basically PVS services crashing.
Yep.
And there is a NetApp firmware update for this, and there is a new log value and timeout value can decrease to make it to work. And this is a Citrix knowledge base article. But sometimes you learn it exists the hard way. So, and we had to do lots of traces because we asked NetApp to get the fix. So, no, just if you are using.
You're talking about the opportunistic locking.
Yeah. It's like an opportunistic locking, but on the NetApp,
the
NetApp side. Yeah.
Network tuning. So there's a whole slew of network tuning that's required as far as offload, chimney, receive side scaling, all these kind of things. Some of these are well documented, but as Pierre said, if anyone wants the specific values we're talking about, shoot us a message or whatever, and we'll send you the optimizations. You can find a lot of these on the internet if you search for PVS and network optimization, but we didn't want to include them all here because it's a lot of registry values and such.
And you have also some best practices, and like Shawn said, for the storage guy, don't trust your network guides because PVS is really sensitive to the network, the network side, and you have lots of features you need to disable on switches. So
good examples of that are you need to make sure there's no spanning tree loops because it will absolutely kill your environment. You need to make sure you don't have speed duplex issues, which should not be the case in a gig or 10 gig E environment, but it can definitely happen in 100 meg environments if you still have any of those lying around. You want to make sure you don't have MTU mismatches. So somebody's got jumbo frame on one side and not on the other side. That can cause some massive issues. You want to check for, there's one more I was thinking of and I'm forgetting now.
I would say no, it was the same.
It was there
MTU, you can have some also MTU issues, but a customer of mine that has something like 800 streams, it's XenApp servers. They have been experimenting random performances issues from 6 months until they realized a network layer was dead on an HP blade. And for the network guys, everything was okay. And it was on the specific blades, but due to load balancing.
The other one I forgot was port fast.
Yeah, port fast, yeah.
So you have to have port fast enabled to make sure when you're doing your DHC Pixie boot that actually gets the network information and is able to attach. Otherwise, you can have issues where your machines restart and they don't actually function.
Yeah, because of spanning tree, actually,
we talked about this one before, just more specifically when it comes to PVS performance. If you're doing a low number of targets, you may get by with a virtualized NIC okay, but if you want a better performing environment or a higher number of targets in excess of 100 or 200 targets, you really want to look at doing a VTD pass-through of the NIC, so you get physical NIC pass-through to the VM, which does prevent your ability to, of course, vMotion that machine. But again, within PVS environments, if you're designing for high availability, you shouldn't need to vMotion for any reason. So I think that's a good sacrifice in my mind.
I am always enabling this so that I am safe.
Yeah, to be sure. It's one of those just in case.
Just like also regarding network, and because we are running out of time, an old best practice was to use Intel driver E1000 on VMware. Now the new best practice is to use VMnet X3. So actually it depends on your version of vSphere.
Yeah.
So
if you're doing 5.0 and above, VMXNet 3. If you're doing older, E1000.
Just trust me, in some cases it's working and not. Like you should not mix it. So if you have VMware 4, use the Intel driver. If you have vSphere 5, use the VMnet X3. Otherwise, it's not working well.
And while we're on that topic, because I don't think I remember to put it in here, be very, very careful about VM tools updates. Oftentimes, and this is true of the VMware solution, it's true of the Xen server solution, when you update tools, there's certain times where there are things included in that tool that are a NIC driver update, and it's bye-bye PVS targets when that happens. So be very, very careful with driver updates. Particularly in the VMware environment, there's oftentimes auto VM tools upgrade enabled in some systems. That can cause a very bad day for you, not only in the case of PVS target XenApp systems, but also in the case of a Xen desktop environment. If you have a Xen desktop environment that the WDM driver comes down, and completely whacks your Zen desktop display driver mirroring, then it's a bad day for you again because all your machines now can't display video.
And actually, you should always install the tools before the PVS client.
Good point. Good
to
point.
be sure that you do not break the filter driver's chain.
So PVS target tuning, we said see chapter 1. We did a bunch of stuff in chapter 1 that we shared. So definitely go back and look at that. Antivirus, obviously, antivirus can make a big impact. We recommend pre-scanning your image. Go see Project VRC's white paper about antivirus and why this is important. Make sure you make good exclusions. And there's lots of KBs out there on what exceptions to make for Edge Site and for PVS and for all these different products. Make sure you've got good antivirus exclusions in there.
So make sure you optimize your file system to reduce your write IOPS. You have some values like AO page lock limit that allows to offload some of the IOPS into RAM. And also what I found as a good best practice is you can just pass.
Yeah, sure.
We will be a little bit faster and skip some of them. Is like you may know something I'm calling the very first boot, which means the very first logon. The first time you log on a machine just after it has rebooted. And it's really slow because it's loading everything. So just imagine how it could be when you're also populating the PVS cache. It's horrible. So from a XenApp perspective, from a user perspective, just sometimes the logon is slow as hell. So it's a good practice to include an auto logon sequence that will then pre-launch like all applications and close them gracefully. We can talk about how to do this if you wish, if you have any question. But then it's also really useful for streamed application because everything is pre-populated. So the first time the user is logging in on the machine, it's just like this. And it's not, sometimes it's slow, sometimes it's fast, which is really negative from a user perspective.
Yeah, the last thing you want to do is have a bunch of streamed applications in a 100-server environment, and a user logs in, and they're waiting for the thing to stream. And if you're not providing the feedback within the app streaming product that tells them how far along they are, they might get mad and close the client or force the client close, try to log again. Now they hit server number 2, the same streaming starts happening, and they're just so frustrated because every system they hit is waiting for this caching to occur. So that can be very frustrating.
Yeah. And also, if you are using RAM cache, reboot daily to force a purge.
Yeah.
If you are using local disk cache, every week should be announced, but you will need to use some scheduling script and stagger the reboot. Do not forget that every reboot will clear the cache, and you will have to repopulate it. And at this time, it will be slow for the first user who will log on the server and launch some applications.
All right. So the last topic we want to talk about is PVS high availability. The most important part about using PVS is to make sure you don't screw this up, because if you do, you'll be polishing up your resume getting a new job. So the most important one that I say is don't ever implement a single PVS server. This is basically your instant denial of service waiting to happen. The stream service will fail, I guarantee it, probably at the most inopportune time. And if you have no alternate solution and all your systems get bounced at that point, it's completely dead. All your servers are completely inoperable. So make sure you design minimum of 2 PVS stream servers in a given site.
And also design the boot solution like PXE or ISO to be fault tolerant. It could be also PXE as default and ISO as backup. You can mix them, but just be sure that even if you have secured the PVS side, you do not forget the boot side, because I've seen some environments, you have 2 PVS but 1 PXE. So if the PXE fails, it's dead anyway. Actually, the machine is still working, but you cannot boot any new one.
Can't reboot it. And on the boot disk side too, a lot of people shy away from the boot ISO thing because they're a little bit concerned about it being retached properly and that kind of stuff. If that's the case, build a small partition, install the bootstrap in there, and just treat it like a disk volume that you attach to the machine as the primary boot volume. It's an easy way to go. DHCP clustering, well, there's different ways you can do this. Infoblox has some high availability DHCP solutions you can use. Certainly you can go and use Infoblox. You can do a DHCP cluster. You can split DHCP ranges being serviced by multiple DHCP servers. Or now in Server 2012, there's a DHCP failover mechanism that's built into the product that doesn't require you to segment scopes, which is, I think, nice because it's not as hard to set up anymore. And it works very, very well, has ultra-fast failover. And so I recommend if you have your DHCP environment in a Microsoft stack, move to Server 2012 for DHCP. It is much, much better than trying to do split scopes in the past.
And I think just to close, because we are just in time, if you have already tested PVS failover, you may have seen it takes sometimes some minutes to find the new PVS server. You can fine-tune it, actually using registry values. It's hidden in some knowledge-based article, but you have some values you can tune to then make it converge really faster.
Yeah.
So it's also useful from a high availability perspective.
So I don't think we have any time for questions. I apologize. We had a lot of information to share. But we'll be around after the session closes out, I guess near the outside of the room. We can chat with you guys if you have any questions. Thank you very much for coming.
Thank you.
Send us a message.